Amazing. So let's get started. Great. So first of all, as Jim said, my name is Eyal Bukchin. I'm the CTO and co-founder at Metal Bear. Just a few words about Metal Bear. We're a small startup. We're building open source dev tools for cloud engineers, or at least that's our grand vision. In reality, we have one flagship project called MirrorD. That's gonna be the main sort of focus of today's talk, or that's going to feature a lot. And the talk is called Tightening the Kubernetes Feedback Loop with Remocal Development. So what's in store for us today? First, we're going to talk about what MirrorD is, who it's for, what problem it solves, and then we're going to dive into the technical details because it really is a neat piece of technology. And then, of course, a live demo because how can we not? So first of all, what is MirrorD and what is it for? So this is very basic, but there's an inherent problem with cloud development, which is that the code is written locally, but it runs on the cloud. And it's mainly tested locally as well. And so it's tested in a very friendly and sterile environment, but once it reaches the cloud, it runs into a lot of conditions that it has not encountered before, and it breaks. Which leads to iterations. And as I said, it's inherent to cloud development, which makes it a problem to everyone writing code for the cloud faces. And this results in a development cycle that looks something like this, right? So it's iterative, and you start locally, you code locally, you test locally as far as you can. Which sometimes is not at all, right? Sometimes your service can't even run on your local machine if it's a very complicated deployment. But it's assuming you can, you then open a PR, you build your microservice, you go through CI, you merge it, you deploy to your staging environment, then you test in staging, and if you were lucky enough to go through all these steps successfully, then you are cleared to deploy to production. But if you're not, then any step where you fail, you have to go all the way back to step one, right? If there's a problem with the code, then of course the change has to be done locally and go through the whole thing again. There's a lot of downtime in this cycle, so a lot of asynchronous steps, stuff like building CI tests, which give you either time to go get a coffee, or if it's a more extreme case, um, start working on something else that's on your desk, which leads to context switches and just pretty much reduced efficacy. Um, so, and this gets even slower and more complex when you're working in an organization, um, because the staging environment, and if we take a minute to define that, right? So that's the most production-like environment that the organization has, that is in production itself. Then the staging environment is usually a shared resource. It's something that's set up once. It's hard to spin it up per developer, either because it's too expensive or there are components that simply cannot be spun up, like heavily populated databases or third-party APIs. And so it's a shared resource. And so when people reach that step of their development cycle, they either queue up in the best case, or they clash in the worst case. And how can we not say a word about AI? But as long as the policy is that new code written has to be tested in staging, then AI agents face that same, or will have to queue up in that same queue, right? So you increase your throughput and code being written, but you still have to test it in that one shared environment. Um, And this is where MirrorD comes in, and Remocal development, right? So Remocal development, that's remote and local, of course. And the way it looks is you're a developer, you have the one or two microservices that you're currently making a change to, and you run those locally on your machine. But everything else is running in staging, right? So it's connected to all the dependencies and staging databases, other microservices, third-party APIs, files, environment variables, pretty much everything. Mirdi fits this into your existing workflow, which we'll see in the demo, but it's a button in your IDE or a CLI command, which basically says, this microservice that I'm running right now, please connect it to my staging environment. And it cuts through the lengthy iterations, the lengthy dev cycles that we just saw, right? Because instead of having all of these steps that you have to go through, you code locally and then you immediately test on staging. Code locally, test on staging, a much shorter iteration with no downtime. So there's obviously a huge gain here in terms of velocity or developer productivity. And this also has implications on the organizational level because Mirror-D, and we'll see this soon, it does not deploy your local microservice to the staging environment. So the stable service that's running on staging, it's still running, it's still handling requests. All this to say, Mirror-D is non-invasive and non-disruptive to the environment, which makes it concurrently usable. So this eliminates the bottleneck of the shared environment that we've seen before, which enables everyone in the organization writing code to take it all the way to production without clashing or blocking each other. So that's a little bit about what the product is, and I think it will all become clearer once we go into the demo. But first, let's discuss the cool technical details. So first of all, just to get context, we have to understand what other people or other companies doing Remocal development are doing, because we're not the first, right? So there are other tools. The most known of them is Telepresence. There used to be a Microsoft project called Bridge to Kubernetes. There are some others. What they all basically do more or less is VPN your machine or your container into the cluster. This has several drawbacks. One is it's pretty susceptible to whatever's going on in your cluster network. So if you have a service mesh or you're working over a corporate VPN, that could disrupt these tools. It requires root permissions on your local machine. And it doesn't support environment variables or files to be imported from the remote cluster. What this translates into is that it's a lot harder to get these tools working on complex setups. So Mirror-D does things a little bit differently. And what Mirror-D does, it injects a library into your local process, the local microservice that you're running, and it hijacks your system calls and it proxies them to the cloud. And we're gonna work through that and explain exactly what that means. So when you start Mirror-D, the first thing you need to do in order to inject yourself into the process and hijack system calls is actually load your code into the microservice. And the way we do this is with something called LD preload on Linux or DYLD insert libraries on Mac OS. What this does is it tells the dynamic linker to load our library into the binary that's currently being executed. So, so this accomplishes actually getting our code into the binary. But then we want to actually run some code, right? So we're in the binary, we want to actually be called. And for that, there's the CTOR constructor function. So we use Rust for Mirror-D. And Rust lets you decorate your function with a CTOR. And what this does is it loads, sorry, yeah, it puts the code into a section of the binary that's called upon execution. So so now we are loaded into the process and we're actually being called. So we can actually run our code. But what do we actually want to run, right? So a little segue here, right? So libc is the standard library, the C standard library. It's used by almost every programming language, not Go and Linux specifically, for which we have some other solution. But what happens is when you write code in Python or Node or whatever, TypeScript, then when you call file read, for example, then that calls the corresponding function or functions in libc, and libc itself calls the kernel. And because libc is used by so many languages, it's a very good choke point for mird to sort of hook on and implement our logic, and in that way become generic for all of these languages without having to provide specific implementations. So as we said, we're loaded into the library. Now we can execute code. We know what libc is. And what mird does is it hooks libc functions, right? And the way it does it is by using a tool called Frida. And Frida is a dynamic instrumentation toolkit. And what it does is it lets you hook existing functions. So it puts calls to your function in the first or in the start of the memory of the functions that you're trying to hook, right? And so when the function is called, it's actually redirected to the code that you redirected to using Frida. But of course, the code doesn't run yet. It's only called. It only runs when the function is actually called by your process. So now we're loaded in. We've hooked libc, and now what happens is that you run your process, right? But it has mird loaded into. Now your process doesn't know this, but of course it calls whatever functions it usually calls. If we take, for example, file read, right? So your process calls file read, mird hooks the underlying libc function, and it forwards it to your Kubernetes cluster, to your staging cluster. Now here we enter another component of mird that we'll expand on in a moment, which is called the agent, right? So the agent is our representative in the Kubernetes cluster, and when we hook the file read function, we send a message to the agent asking it to read this file from the cloud instead of the local machine. So that's the way we proxy functions to the cloud, and we return the answer or the response to the local process, and it doesn't know that it actually received a file from the cloud. Now, the nice thing about this mechanism is that we can control exactly what happens remotely and what happens locally, right? Which is another advantage on top of the VPN-based solutions. So when the hook is called, we actually, before executing, check the configuration to see if we actually want to run it on the cloud. If we don't, then we just revert to the original implementation. Sorry. Now let's talk about what happens in the cluster. So first of all, when you start mird, you specify your local microservice that you want to run, and then you also specify something we call a target. The target is the pod or deployment or Argo rollout for that matter in the cluster whose context we want to import locally, right? So the most common use case for Mirror D is, I have a stable version of my microservice running in staging, and I'm now working on a new version, and I want to test that. So in this case, my target would be the stable version of my service running in the cluster. Now, the agent, it runs in a pod. It's on the same node as the target, and it enters the network namespace, Linux namespace of the target, and this lets it execute these functions that we're proxying on the target itself. So in the end, the resources that we import, which is basically all of the input and output points of your local process, is networking. So DNS, incoming and outgoing traffic, file system access, as we mentioned, and environment variables. And this is how it all comes together, right? So you run your process locally. Mirror injects itself into the process. It proxies all of the hooked functions to the agent, and the agent executes them on the target. Now, something that I didn't mention is that it also goes the other way, right? So if there's incoming traffic to your service, the agent listens in on it and sends it to your local process. The end result here is that your local process runs the same as you always do, as it always does, but it thinks it's running remotely because we cover all of the exit points. So I'll move on to a demo. So for this demo, I'm going to for the purpose of this demo, I'm going to be working on this architecture. For this matter, this is my staging cluster. So I have a service called the IP visit counter, which counts the number of times an IP has accessed it. When it receives a request, it saves the IP to Redis. It gets some extra info about the IP from another microservice. It sends a message to Kafka, and then it returns a response to the client. All right, so I'm just gonna do this.
And this is where bonus points for live demos. I have some speakers that do live demos, and I'm always like, yes, live demo time.
I didn't realize it was a bonus. I would have done two. So, can you see my ID?
Yes.
Actually, sorry, 1 second. I'll share my whole screen because there's going to be. Is this okay? Can you see it still?
Yes.
Okay. Great. So I'm using IntelliJ Goland. Mirror comes in a few flavors. So there's a plugin for IntelliJ IDs. There's a plugin for VS Code, and there's a CLI tool if you don't use either of those. But I'll use Golang for this example. I have the IP visit counter code loaded here, and I have my staging cluster. So you can see all of these services that I mentioned before. They're all running on Kubernetes. So that's we've set the stage. Now, when I install Mirror and Mirror is available from the marketplace for the respective IDE, I get these two little additions here. So one is a toggle button that just enables or disables Mirror D, doesn't do anything by itself, and some settings which we'll look into later. And so when I enable mirrord, and then I run my process, I get this pop-up, right, of showing me all of the possible targets in my cluster. So as I mentioned before, the target that I'm going to use for the IP visit counter is the deployment or the pod for the IP visit counter running in the cluster. So let's do that. Oops, sorry. Okay, so we are now running with mirrord loaded. And note that I didn't have to make any code changes or anything to my process to accommodate mirrord. So we're in the main function, and we have a load config function which just gets some environment variables, and these are all loaded from the cluster. So stuff like the Redis address, Kafka address, etc. All of this configuration. Next, I'm going to try to read a file. This file does not exist on my machine. But of course, because mirrord tries to read it remotely, then, 1 second. Sorry, then it succeeds, and it gets the file. Remote is fun. And then it's going to do some more complex stuff like connect to Redis, connect to Kafka. And the nice thing here is that because we override everything, right? So environment variables, files, network, DNS, etc., then complex flows are supported out of the box without you having to make any adjustments, because I'm getting the connection string from the remote pod, and then I resolve to an IP using the remote DNS, and then I access the IP through the remote pod, right? So everything works as if it was running remotely. So that's my setup function. And as I mentioned before, there is the matter of incoming traffic. So this cluster is accessible over the internet. It's at this domain, and I can just curl. Oops, no breakpoint. 1 second. Yep, so curl to this path, and my breakpoint is hit. Now, something to mention here. By default, mirrord mirrors, hence the name, incoming traffic, right? So what does this mean? You can see that I've already received a response to my curl request. Because what happens is mirrord, the agent, reads that incoming request. It sends a duplicate of it to the local process, but then it just forwards it to the service running and staging, and that's the service that answers the request. So it's completely transparent to anyone else using the environment, and the response from here is discarded. So this lets me debug how my service processes incoming traffic without affecting the environment at all. But what if I do want to affect the environment, right? What if I want to test a more complex flow? For example, I receive incoming traffic, then I write to a database, then I return a response. I want to see what my response looks like. So with that, we have some settings. So when I go to the menu and go to settings, it creates this file if it's not been created before. The mirrord JSON, all of mirrord's configuration is controlled from here. It's populated with some default values, and we see that we have this bit, right? The incoming network key. We'll change that from mirror to steal. We'll run mirrord again. just run through the setup code. We don't need that anymore. And we'll curl again. And we can see that the curl request has not returned yet, because it's now waiting on me to return the response. So it's going to be blocked until I release this breakpoint. And then one last thing is, so we talked about sharing environments, right? But if I steal all of the traffic for a specific service, then that's not very, considerate, right? That's not very transparent. I'm basically holding a mutex on this service for as long as I'm debugging it. And the way we solve this is with something called the HTTP filter. So I'll just show you what it looks like. Just 1 second, sorry. Sorry, just gonna fix my screen share real quick.
All right.
So switch those around, HTTP filter. Great. So I can, sorry. Oh, okay. So I can specify a header. So we'll say something like this. Actually, and before we do that, I'll also make a little change to my code. So I have the response here, which just says hi. So we'll do that. Great. So now we're listening. And if I send a request without a header, then I can see that the text is unmodified, right? So just hi. But if I add a header, is that the wrong one? There we go. So I hit the breakpoint. And I get my response, right? My modified response. So this lets multiple people use MirrorD on the same cluster without interrupting each other, even if it's the same service, right? So yeah, so that's the demo.
Yeah, that yeah, the ability to steal just selectively. Yeah, if you're in a just one guy doing everything, stealing everything, maybe it's okay. But yeah, with any number more than one developer, yeah, that's great to be able to steal selectively, and they don't have to. set up any special headers ahead of time to steal. You can just look like on the fly. This is the header that I want to put in, that I want to steal, then start sending test traffic with that header, and then you'll see that it's it comes to me. You won't see it. It won't affect anybody else. So that's pretty cool.
Yeah, exactly. And it's in reality, a lot of those run through multiple microservices, right? So you might not hit the endpoint of the actual microservice that you want to debug. But then setting up header propagation pretty much solves this, and it's usually pretty easy to do. And another thing is that a lot of organizations also use personal environments, right? So per developer environments. We do not encourage this, but it happens. And Murdy can be valuable there too, right? Because even if you use a personal environment, there is some downtime in iterating against that environment, but Murdy lets you work against it in a more streamlined way. So, and then of course you can steal everything and do whatever you want.
I've got a couple questions about the setup and the flow and the kind of the technical requirements. So it looked like you're working on a Mac with you said it was with IntelliJ, one of the JetBrains products, not IntelliJ, because you're using Go, not Java.
Yeah, Goland.
If you're on Windows with IntelliJ, is Windows supported? Is Java supported? Anything? Yeah, maybe list off some of the things that are supported or not supported.
All right. So Windows is supported with WSL at the moment. We are working on native Windows support, but it's through WSL at this point. As for languages, everything is supported so far as we know. Yeah, I mean, I mentioned before the one example that we found that doesn't use libc and hence wasn't supported is Go on Linux, but we did some stuff there to support it. There's some assembly in the code. Don't worry, you don't want to hear about it, but it works. So yeah.
So we have a question from Jay Ram in the chat. So you did show that it was connecting to a Kubernetes cluster, but he missed the part of how Murdy was communicating or able to communicate to the Kubernetes cluster, and maybe this is a follow-up for me. Maybe what besides having the Metal Bear agent out there on the node with the pod that you want to target, how do you connect? If you can go through that in a little more detail, how that kind of remote connection works.
Yeah, I mean it's pretty simple because it's all over the Kubernetes API, right? So let me just put up a drawing.
Sure.
Right, so it's just the same one, right? But just so we have it here. So when you initiate Murdy, it uses your existing kube context. It creates the agent pod through the Kubernetes API. And then it connects also to the Kubernetes API to the agent through a WebSocket. So that initiates that channel of communication between the injected part, what we call the Murdy layer, and the Murdy agent. Does that answer the question?
Yeah, we'll see if Jay, if that answers the question, just put it in the chat. Wait a second while he's typing. While Jay's typing, I'm thinking whether that answers or not. There's a somewhat long question from Abdul. Great session so far. Couple of questions. We'll maybe take these one at a time. Does Murdy work with complex hybrid processes, like instead of native cloud Kubernetes like GKE EKS? Does it work with something that's Anthos GKE that's hybrid, like Do I need a special version of Kubernetes for it to work with, or is it any Kubernetes? Maybe there's a version minimum that it works with.
No, I mean because it's over the Kubernetes API. We don't really care where the Kubernetes is running, right? GK, KS, etc. It doesn't matter to us. We're agnostic. Um, I'll have to get back to you about a minimum Kubernetes version, but it's nothing recent, right? Like we know that we're working on pretty old versions. So
Okay. All right. Jumping back to Jay. Jay says, he gets it. There's a cluster side process running. Is there a Helm chart for the agent or something that helps easily install the agent?
okay, that's a good question because I didn't touch on this. So the agent is transient, right? It's ephemeral. When I start mirror_d, then mirror_d creates the agent, right? Itself. You don't need to have it running persistently in your cluster. When the mirror_d session ends, when you stop the debug process, then the agent is cleaned up. So there's no Helm chart or anything you need to do on your end on the cluster.
All right, cool. So going back to the list of questions from Abdul, does mirror_d work well? Similar technologies, for example, instead of using Redis, could you have GCP memory store instead of using Kafka? Maybe PubSub. Are you seeing
Yeah.
anything that mirror_d has not been able to handle with some kind of technology in the ecosystem?
So the traffic support is TCP based. So anything communicating over TCP that's supported, which is most things. There are some pretty arcane protocols that we've run into that are not supported, but it's very uncommon. So
All right, cool. And one more question in the list here. So in the topic of stealing the incoming traffic, in regards to logging, will the log show up only in the terminal, or would it show up in whatever logging mechanisms I have? Because some traffic's coming in, it's getting stolen or mirrored. I guess how does that affect logs?
so if you're asking about logging in the cluster, um, then it doesn't, like, the traffic doesn't reach your the target service, right? We use IP tables to redirect it to the local process, and so if you're counting on the that service to log the traffic, then no, it's not going to be logged. If you but it's worth noting that the pod works at the at the pod or deployment level of the service that you're targeting. So for example, if you have a reverse proxy in front of it or something like that, then you're going to see the traffic there because mirror_d comes after.
Okay, so just depending on where it gets stolen, it doesn't get stolen necessarily. It has to come into the cluster. It has to come into the pod. Then it can be stolen. So if anything was logging ahead, you'd see you'd see that traffic coming through.
Exactly. And for mirroring, of course, it's going to be logged because it goes through that same route that it usually does.
Mm-hmm. Say I'm just thinking through, trying to get in my head how it works. Say I already have an ecosystem of like 10 microservices, and I wanted to add one more. Do I have to have the first version of my 11th microservice out in the cluster before I can use mirror_d to
Okay.
see how it
Yeah.
interacts?
Yeah, that's a great question. So mirror_d also supports a mode called targetless, which just it just teleports your local process to the cluster without piggybacking on an existing service, which gives it outgoing access, to environment variables, to mostly just outgoing traffic, right? So access to other resources. So no incoming traffic for that matter. But yeah, that's the support we offer for new services at the moment.
Okay. So it basically bootstraps itself out there, projects it from my laptop out there. I don't have to have an existing service running in the target cluster.
Yeah, exactly.
All right. I just want to check. Did you have? I know you went through the whole demo. Did you have more things to get to? Because I think we can probably ask questions for the next 15 minutes easily.
No, it's just this. So just the contact. So feel free. I'm happy to answer more questions.
Uh, yeah. So I just glanced over at the chat. Didn't see them. Didn't see anything there.
Uh,
So yeah. So you can target any Kubernetes. There may be a minimum version, but it's just using the Kubernetes API. Uh, it's going to be not technical on how it's laid out, but kind of company culture and security culture wise. They've kind of a couple questions. First one is on, in your example, you're just doing like the integration environment, not production. I'm assuming this could be used in production, but maybe in only break glass emergency. I need to debug something, and like I don't really want to do it, but it's the fastest way to see what's going on and actually run through a debugger, which would be pretty cool. So, but how do you get security guys that can be, they're notorious for saying no and not liking new things, but how do you approach a CISO's organization or a cloud security guy and say, hey, that get get Metal Bear in
yeah,
there?
yeah, yeah. One DevOps guy once told us, this is basically a rootkit. So I'll first of all, for production, not something we encourage or assume liability for, but there are organizations that use MirrorD in production, not even in break glass emergencies, which is I guess it depends, right, on your product.
Yeah.
So I didn't want to get into this, but we do have a paid product. This is where we address security concerns and basically make MirrorD enterprise ready in various ways. One of which is that we have a centralized component called the operator, which does the pod creation, which is usually what bugs the security people, is that everyone in the organization can now create pods with a little bit like slightly elevated privileges on the shared cluster. So so this centralized component is the one doing the pod creation. It also adds a layer of RBAC and policies that lets you control how this is done. So yeah, this is one of the ways that we um, sort of allay the fears. And of course, in the end, it's a staging environment, which is not often that sensitive. So it
Yeah,
really depends on the organization.
yeah, staging. You shouldn't have real credit cards or any kind of stuff like that. You shouldn't.
Yeah, well,
Yeah. So just to wrap that into like 10 seconds or less, MirrorD, which we can download from GitHub and just use. That one we can do everything that we've seen. Metal Bear kind of tries to take that to the enterprise, adding in additional RBAC and identity and access management type things that security guys would want. Is that the difference?
yeah. So there's that, but the main difference is sharing environments, right? So really lean into this use case with the paid version. So I'll give you an example, right? So something that we didn't touch on is event-driven services, right? So what
Mm-hmm.
if you and me both want to work on a service that reads from the same Kafka? We're going to be competing for messages, right?
Mm-hmm.
So just as an example, we provide a feature called queue splitting, which lets you basically split your Kafka into two queues for the duration of the session, handle it that way. Um, So that sort of thing. But
Mhm,
yeah,
mhm.
basically we just enable organizations to use MirrorD on a large scale in a shared environment.
Gotcha. All right. So Jay has another question. So he says the MirrorD agent on the cluster side, it's operating by taking over the service, he presumes. Does it also manage external load balancers when they are talking to app services? I'm not sure if I'm getting the question, but because you'll have inbound traffic, it should hit any load balancers coming in. AJ, are you talking about like outbound load balancers, like if it's communicating outbound?
Yeah, so it's not really used. It doesn't take over the service, right? So as I mentioned, the agent is created on the network namespace of the pod, or really the pod, and it sniffs traffic from that network namespace for mirroring, or it manages or modifies the IP tables for that pod to steal traffic. So it doesn't really work on the service level. And it's not aware of anything upstream of that service. So load balancers, reverse proxies, that sort of thing, transparent to MirrorD. So I don't know if that answers the question, Jay, but yeah.
All right, I think it does. Uh, so Alexandra, is Alexandra with you? It seems to be answering the oldest Kubernetes question. MirrorD was Kubernetes 1.2.15.
Yeah, that's an insider. I didn't know I had one. So all right, good to know.
All right, now I have a completely non-technical question. So I want to ask every speaker. Sometimes we get some kids in college or fresh out of college, and usually the speakers are seasoned technical veterans, been in the business world. Uh, Anything that you would tell yourself if you went back in time and talked to 20-year-old you, or someone coming out of college now? Any kind of tips or advice that you like to share on how to have a successful life or a successful career?
I wish I knew. Yeah, like I need 60-year-old me to tell me now. So yeah, that's a good question. I don't have anything, really ready, but I guess try to build a company earlier than when I actually did it. It took me a while to get there. It took a lot of courage. Took a lot of from my end. It's something that I avoided for a long time, and it's great. It's a great journey. It's a great experience, and I wish I'd done it sooner. So yeah, that's
So if you have an inkling, an idea that you want to start your own company at some point, just give it a shot.
yeah, I
What
think so.
and about doing it earlier? Is it? Do you think it's so enjoyable you wish you were doing it earlier, or you wish you did it earlier because maybe there's less risk because there's less overhead? I don't know how to put it, but are there any? Is it a bunch of different reasons for starting it earlier?
First of all, I think I would have just, had more years of enjoying what I'm doing more, so there's that. And I think there's an advantage to doing it young, in terms of personal commitments, in terms of personal sort of runway. So so there's that. Yeah, just off the top of my head.
Yeah, no, that's great. Yeah, you don't. It's great for off the top of your head. Follow up question from Mateo on this line of thinking. What do you think made you start when you did start, and then what do you think was holding you back from starting earlier?
So I mean, what was holding me back? I was on a very safe sort of path. I was working my way through the ranks of engineering management, and it was comfortable, and it was hard for me to get out of my comfort zone. And what eventually pushed me there were circumstances, right? So I found myself sort of forced to leave the company I was working for because I had to relocate for personal reasons. Um, at the same time, I I worked with my co-founder at that previous company, and he left at the same time. And so just this timing of both of us leaving, it made sense to try to do something together. So really just, lucky, fortunate circumstances eventually pushed me over the edge. So.
All right, well, that's great. So, any other questions from the chat? Mateo says awesome. And yeah, any other questions in the chat? All right, none from Abdul. That's one. Kubernetes has been, was it almost on its 11th year now, something like that. Microservices hasn't, I don't think microservices have died. They're probably getting even more complicated. So I think having at least an option of a tool so you can work on it now, right now, put it into my working environment, see how it works, or debug it, or try something else. It can save resources because it would be great to have my own Kubernetes cluster, my own development environment, but nobody has unlimited money for cloud spend. But yeah, to have that Mirror-D and then Metal Bear kind of taking it to the enterprise level, I think it's a great option. I haven't seen, besides the VPN options, anything at kind of at this level. So yeah, I really appreciate you taking the time to join us. A lot of work behind the scenes to build it, and then taking the time out of your night to join us, show us what's out there, and share a little bit about what kind of got you into starting the company and why. It was really great having you.
Yeah, pleasure. Thank you so much. And yeah, try it out. We have a community Slack, and we're very responsive. We like to think so. Come talk to us.
So I'll collect the slides from you and share it with everybody. It'll have the extra contact information on the last slide. I'll post those. They'll be on the event site. So just scroll down the same site that you joined from. Just scroll down. By Monday, I'll be done with the video and have the slides up. And usually before Monday, but I usually say Monday in case I get too busy to do it. So check it out there. If you think it's interesting for people that using Kubernetes, feel free to share it. It's great to share things that we find that look interesting. So share it with your friends. And if you have time, there's another part of our GDG Cloud Southlake sessions that we do. We do a little virtual networking. So I'll put up a 5-minute timer. If you are available, stick around. If not, no worries. We'll see you at a next session. And Eyal, yes, once again, really appreciate you joining us and showing us this. I don't want to say cool too many times, but I just got to say this cool technology.
That's what we like to hear. So